Before we jump into Unit 9, we need to talk a little bit about regular polygons. Regular polygons have sides that are congruent, all sides are congruent, and all angles are congruent. A couple of familiar ones are this equilateral triangle. You know that all sides are congruent and the angles are 60 degrees. A square, all sides are congruent and the angles are 90 degrees. Got a pentagon, hexagon, heptagon, and octagon. Now, as we go through these, you've heard of those before. Um, and, wow, there we go. Um, so the question is, what can we do with these? Now, I probably won't make you work with a heptagon, which has 7 sides. You're going to work with a hexagon, definitely. Want you to know what an octagon is. That's a 8-sided figures, right? So, in as we go through this, 3 sides, 4 sides, 5 sides, 6 sides, 7, and 8 sides. All right, so if we start out with this thing called a equilateral triangle, we need to define some terms. And if we define these terms so that we understand what we're talking about, you're going to be given problems based on these terms. Now, if I were to take this equilateral triangle and if I were to go through and draw a beautiful circle right around it, and apparently that wasn't a beautiful circle, right? If that was a circle that touched each of the angles there, we now have a or circumscribed triangle. The radius here is defined as that length from the center of the circle to the vertex. Okay. So they're going to talk about the radius of a circumscribed triangle, things like that. The next one, what happens if we were to inscribe this triangle? Again, let's see if I can make a beautiful circle again, which I obviously didn't. There we go. Now that's inscribed. Now I've got another, and again, theoretically that's the center, right? If I draw in the radius of the inscribed circle, that's going to give you a perpendicular line. It's going to bisect that side. We call that the radius of the inscribed circle. We're also going to call this an apothem. Okay, always going to be a perpendicular line to the side that bisects the line. We can do that with a square, so we would define the radius is going from the center of the square to the vertex. And again, that's going to be half of a diagonal, isn't it? From the center, if we draw it straight down, that's the radius of the inscribed circle, but that's also called the apothem. We can keep going. If we find the center of the pentagon, we've got the radius, we've got the apothem, and again, keep in mind that's going to bisect that side. All right, so the polygons, by definition here, a radius of a regular polygon is a segment joining the center to any vertex. We've talked about that. We know what that is. From the center to the vertex, that's the radius. An apothem of a regular polygon is a segment joining the center to the midpoint of any side. And again, I drew it down, but it goes to the midpoint of any side. From there, we're going to give you a formula. The area of a regular polygon, and you probably need to write this down somewhere where you have access to it, is 1/2 of the apothem times the perimeter. Now, I'm going to go back and derive that formula. All right, I'm going to try and do this quickly because of time, but if I were to simply draw at the center, you've got the apothem, and you have a triangle here, right? A right triangle, and we can go specifically into what kind of triangle that is. If I give you P as the perimeter, right, then this side here is P divided by 3. This side here is going to be P divided by 6, or 1/6 P, okay? The area of the triangle we know is 1/2 base times height, which is 1/2 times the base is 1/6 P times the height, which is the apothem, or I get 1/12 times P times the apothem. Now, notice that I have, in this case, how many of these triangles? Looks like I got 6 of them. If I multiplied that by 6, I'm going to end up with the area equals, the 6's cancel, I end up with 1/2 times the perimeter times the apothem. Pretty cool formula that works for all polygons. One more formula I'd like to introduce, and that formula again comes from area equals 1/2 base times height. Knowing that if I draw in this, right, and I label this side S, then we know that this has to be 1/2 S. This is a 30, 60, 90 triangle, right? That means my height has to be 1/2 S root 3. So plugging all this information in, my area is going to be 1/2. The base is still S, right? That whole thing is still S times the height, which is 1/2 S square root of 3. Well, the 1/2 times 1/2 is 1/4. S times S is S squared root 3. We like to write this as side squared root 3 over 4. This is a formula for the area of an equilateral triangle. Write this down so you have access to it. You're going to see me refer to it. Okay, so now we're going to go a couple of examples here. A regular polygon has a perimeter of 40 and an apothem of 5. We know that the area equals 1/2 perimeter times apothem. So step 1, there's the formula. Step 2, plug it in, 1/2 times 40 times 5. And now plug it into a calculator or do the arithmetic. 20 times 5 is 100 units squared. Don't make that harder than it has to be. The formula is ugly, but you can still do this. An equilateral triangle has a side of 10. Find the area. Well, we've got 2 ways of doing this. One, area equals side squared root 3 over 4, or area equals 1/2 perimeter times apothem. Well, let's do both of them. I think the first one is the easiest. Equals 100 root 3 over 4. 4 goes into 100 25 times. Units squared. For the second one, our perimeter is 30. We don't 30. 30. We don't know the apothem, but we could certainly find that out because this is a 30, 60, 90 triangle, right? This is now your 30-degree angle. If that's 5, this is 5 root 3. So the apothem is 5 root 3. And now I can plug it into the formula. 1/2 30 times 5 root 3. Half of 30 is 15. And we see I've made a mistake, you guys. Let's correct this before we go too far. I should have labeled this as this was supposed to be x, this was supposed to be x root 3 equals 5. Therefore, x is equal to 5 divided by root 3, or 5 root 3 over 3, which you guys remember that. So that means this here is incorrect. This is 5 root 3 over 3 over 3 over 3. Now I'll get the right answer. All right, so if I factor, right, this is 2 is going to go 15 times, 3 is going to go 5 times, and I end up with 5 times 5 is 25 root 3 units squared. And I apologize for confusing you on that, you guys. Number 3, area of a circle of radius 6 is inscribed in an equilateral triangle. That's 6, right? Is inscribed in an equilateral triangle. Find the area of the triangle. We know that's our apothem, right? We also know this is 30, this is 60, so therefore we now know that this is my x. This is going to be my x root 3, which implies if x is 6, then x root 3 is 6 root 3. My perimeter is equal to 6 root 3 times, how many of these segments do we have? 1, 2, 3, 4, 5, 6. So times 6, or 36 root 3. Area equals 1/2 perimeter times apothem. 1/2 times 36 root 3 times the apothem of 6 is going to give us 108 root 3 units squared. And again, you could have found this another way. You could have figured out that the side is 12 root 3. So therefore, area equals side squared root 3 over 4. And let's do this real quick. 12 root 3 squared root 3 over 4. 12 times 12 is 144 times 3 root 3 over 4. 4 goes into 144 equally, right? 3 and 6 times 3 root 3, which will also give us 108 root 3 units squared.